Hello and welcome to the SANS Intro to Linux video. Now, this particular video is put together for any and all SANS classes that use Linux as one of the operating systems for the various labs. But we're going through the Intro to Linux section that we provide for SANS 504, Hacker Techniques, Exploits, and Incident Handling. To that end, my name is John Strand. I am a co-author of SANS 504, Hacker Techniques, and Incident Handling. And today I'm going to walk you through some basic things that you'll need to get started on Linux for using the operating system for SANS classes or whatever you decide to do when working with Linux. Now, first things first, don't panic, okay? I know a lot of you that are new to Linux are completely freaking out because you've been on like message boards online. People have said, well, you know, Linux is really hard. Don't worry. Linux is not that hard. In fact, it's a lot easier than a lot of other operating systems, like Windows, for example. A lot of people that believe that Windows is easy and Linux is hard, once they start learning how Linux is structured and how it's set up, they learn to stop fearing the operating system. Also, whenever you're progressing in your career, you shouldn't look at operating systems as kind of a religious avocation. An operating system is merely a collection of tools that you use to be successful in what you do in your day-to-day activities. And to be honest, to be completely successful in computer security, you have to learn how to use Linux. That's why a lot of our classes, like our forensics classes, our network intrusion detection classes, and of course, our pen testing, hacking, and security classes use Linux so incredibly heavily. Now, the goal of this particular section is not to make you an expert, but it's to just kind of get you introduced to Linux in a nice, gentle way without having a bunch of people telling you to RTFM, which, by the way, stands for Read the Fine Manual. First and foremost, some ease of use shell tips, okay? Whenever you're using Linux, sometimes you'll see a Linux guru just go flying through how they use their Linux operating system. And you're just like, my gosh, how are they doing that so fast? Well, one of the things, excuse me, is Linux has a command history. Let me show you what that looks like. So for our Linux demonstrations, I'm going to be using the Active Defense Harbinger distribution. This is freely available. You guys can download it online. And it's available out at SourceForge. If you just Google Active Defense Harbinger distribution, feel free to play along. Now, if I hit the up arrow, you see that I have a bunch of commands in my history. That's because Linux is smart enough, or more accurately, using bash as your command prompt. But Linux is smart enough for you to basically create a history file of all the commands that you've run on that system. So if you see someone that's just flying through rerunning commands, it's because they're using the up arrow. It's not a lot of magic, it's just, you know, they're using the up arrow to run different commands. So that's pretty neat. The next thing that's available is we can also use tab autocomplete. Now, this is absolutely essential whenever you're using Linux, and it's absolutely essential if you're planning on going through some labs in various SANS classes. Because some of these commands get really long. And you see people type them that have used Linux for a long time, and it looks like they're just typing at lightning speed. Well, that's because tab autocomplete. So if I go to my command prompt, and I type cd / I hit OP, and I hit tab, it autocompletes for me. If I type WEB, I hit tab, nothing happens. But watch what happens when I hit a second time. It shows me that there's two separate directories that have web in the front of them. So if I hit L, it autocompletes for me. Get into the habit of using tab autocomplete for everything you do when using Linux. It'll help greatly reduce the amount of typos and problems that you ultimately run into. You also have a history search. So if I use Control R and then I start typing something, it's going to basically search through my history and it's going to bring any of those commands back. So let's take a look at that. So if I do CD to Web Labyrinth and I do Control R and I do CD, you can see it has the history there. So now all I have to do is just hit enter and it automatically reruns the exact same command. That's hitting Control and R at the same time. And then it'll go through and show my history. All right? So that's very helpful when working with the Linux and Unix command prompt as well. Now, let's say I've got a whole bunch of things running on my screen. And it's starting to get cluttered. And this is going to happen in your SANS class. You're going to run a whole bunch of commands, and your screen's going to have all kinds of stuff set up on it, and your screen's just going to look like this. And the only thing you want is just to make it a little bit cleaner. If you do Control L, bang, it completely cleans it off, and you now have a nice command prompt to work from. Now all of your files and all of the things that you typed are still present. It's still there. It just puts it over the top of the screen, making it a lot easier. Sometimes it helps to clear the head, clear the screen, and move forward. Control C is what will kill a current command. So if I go to a file, let's say I have, let's do the README. If I do less README, all right, I can go through the file, and if I hit Control C or Q, it allows me to quit out of that. If I run a program that's going to take a while on the computer system, I can hit Control C to end that particular program. So if you're in less, you want to get out, try Q, or if you're in a program that's running, hit Control C and it'll kill that particular program. Very, very, very helpful. All right. Now, account stuff, whenever you log in. Whenever you log in, you're going to have something called a prompt. Let me talk to you about what a prompt is. A prompt is a little indication as far as who you are on the computer. Now, by and large, on most Linux computer systems, when your prompt is a pound prompt, that thing that looks like a tic-tac-toe game, that means you're root. That means you're super user. Root is all powerful. If you have a $sign, it means you're not root. So if I go back over to my Linux computer system and I zoom in, you can see that my command prompt is a $sign. So if I do ID, it says that I am ADHD. If I do who am I, it says that I am ADHD. And that's a $sign. That means I am not root at this point. That means I'm just a standard user. Nothing too terribly special about the user. It's just I'm a standard user. Now, throughout the SANS classes, we have a very consistent kind of iconography, I guess. If you look at the notes, if you need to be root, it's going to be a pound prompt. If you need to be a user, you can be a user, you need to do just the standard command. Now, whenever you see commands and they start with a pound prompt or a $sign, you do not have to type the pound prompt or the $sign. You just type the command after it. Right? And then also, whenever you log in as not root, you're going to be in a home directory of a user. So whenever I first log in as ADHD, if I type pwd for print working directory, it says I'm in home ADHD. That is where you go. That is your home. So that's what kind of happens whenever you do a Wizard of Oz moment. You're going to be at home. There's no place like home. We'll talk more about that. All right, now one of the first things you're going to want to do on your Linux or Unix computer system is change your password. You're going to need to type passwd. Now this particular command right here gives us a little bit of an indication of the mindset of people that came up with Linux and Unix. They hated typing because typing password was just far too difficult for them to type. You've got to type passwd to change your password. And this is just good practice to change your password to the VMs. And the reason why is a lot of other students in the class are going to have the exact same VM with the exact same user ID and password. So change it to something that you can remember. You don't have to go overboard and create a super secret awesome password. Just make it long and something that you can remember. We recommend passphrases at the SANS Institute. Now, I talked a little while ago about how I'm currently logged into my ADHD VM as a user called ADHD. Now, if I wish to become root, I can use the su command. If I want to know who I am, I just type who am I, and if I want account details, I can use the ID command. So let's jump over to the VM and let's run through these. So the first thing is, if in life you ever get lost and you don't know who you are, no worries. Linux has a solution to that problem. You just type who am I. Type who am I hit enter, it says I'm ADHD. If I want to know what types of groups and permissions and roles I have on the computer system, I type ID and it'll tell me all the groups, all the permissions that I am currently able to use. But I'm not root. You see, I'm going to want to become root because a lot of labs at SANS will require you to become root for those labs. To do that, we use SU. Now that stands for switch user. Now, you can switch user to any user you want as long as you know the account name and the password. You can become that account. If you do not specify account, it's going to assume that you want to become root. So if I do SU space minus, that minus is really, really, really critical because in Linux, and even on Windows, as a matter of fact, you have something called your search path and you have environmental variables. Whenever you use that minus, it tells you to bring the environmental variables of the account you wish to become. That's really critical. You got to do su space minus if you wish to become root. Now, if I do su space minus, it's going to ask me for the password. Another way I can do this is sudo su space minus. It asks me for the password. And I can type in the password for the account, and now I'm root. Now, some systems on SANS, you just do su space minus, it's going to ask you for the root password. And other ones, you'll be using sudo su space minus, where you use your own password to become root. Now, sudo means switch users and do something. So that is where you can use your user account to do kind of quick administrative level functions. Now, if I do who am I, it says that I'm root. If I do ID, it says that I am root on the computer system. So I just became root. Now, root, as I mentioned earlier, is the most powerful account on your Linux and Unix computer system. Let's talk about the file system structure. Now, whenever I first logged in as student, if you guys remember, I was in the home directory. But now I'm logged in as root. What's root's home? Well, root's home is root, okay? Root's home is the root directory. And you can see these various directories by running pwd, and you can see that I'm now in the root directory. That's root's home. If I wish to go back a directory, I can use cd or change directory ... That means go to the parent directory, and I can type ls and it'll list out the directories. And there's a whole bunch of different directories here, but you see that we have root, we have boot, we have bin, we have cd-rom, we have mount as well. So there's a number of directories that you see. One of them is bin. If I cd into bin, and I type ls, these are all binaries, or as we like to call them, programs. So these are the programs that you can access. We have netcat, we have copy, we have fuser, which doesn't stand for what you think it does. We have IP, we have ifconfig, all kinds of different commands available to you to use. Now let's talk about etc. Etc is really cool. One of the neat things about Linux and Unix is Linux and Unix allow you to kind of separate your executables from the configurations of those executables. So if I cd into the etc directory, you're going to see a whole bunch of conf files and a whole bunch of program directories. The blue ones that you see here are directories that I can access, and then these other files are just standard configuration files. By separating out the executables from the configuration files, it actually is a very powerful concept because it makes it easier to distinguish where these things are. Now, this is very different from Windows, where you have executables, you'll have configuration files, and then you'll have some configuration in the registry as well. It can get a bit confusing, but just understand that on Linux and Unix systems, you'll have binaries, executables. Many times those are in bin and sbin. And then you will also have configuration files, and those are generally in etc. as well. That's pretty cool. Then we have lib. Let's go to the lib directory and let's take a look around. So now if I jump into the lib directory, I type ls, we have a whole bunch of SO, or shared object library files. Now on Linux and Unix, you have libraries, and this is pretty much the same concept as Windows. If you guys know dynamic link libraries, or DLL files, those are libraries of functionality for your operating system and for the applications that run. On Linux and Unix, same thing. You have a whole bunch of libraries of functionality that can be invoked. So those are your core libraries as well. We also have the mount directory. If I cd to the mount directory, I shouldn't have anything in there right now. But whenever you plug in like a USB drive or you plug in a CD-ROM drive on your computer system, it's going to put it into the mount directory. It's going to install it in the mount directory by and large. It's going to install it in the mount directory under most situations. In other situations, it's going to put it into other directories, like my version of Ubuntu here on the ADHD instance has something called CD-ROM. If I put it in a CD-ROM, it's going to show up there. USB many times will show up in media as well. They'll show up in different places. And that's different from different flavors of Linux and Unix. It's one of the things that I don't like about a lot of newer versions of Linux and Unix. Everything should be in mount, but they're trying to put it into other files and directories to make it easier for users. We also have the proc directory. Now, proc is kind of interesting because proc actually doesn't really exist on the hard drive. If I type ls and proc, you see all of these numbers. All of these numbers are the process IDs for the various processes that are executing on my computer system. So if I cd to 14 and I type ls, you can see we've got the executable, we've got root, we've got the page mount, IO, latency. The proc file system exists whenever the computer is running. Now you don't really have to worry about a lot of this for most of your SANS classes, it's just good to know. Temp is for temporary files. And of course, you'll have user binaries, man pages, which we're going to talk about here in a bit, and service binaries. And then of course, var for variable files. And that's where the vast majority of your logs exist on Linux and Unix. All right, so navigating the file system, you've seen me running these commands. It's the cd command, the change directory command, is what you'll use to navigate around the file system. Very, very similar to what we do on Windows as well. Now, if I go cd to, let's say, /, that takes me to the top of the directory structure on the file system, and then I can work down from there. So I can just cd that. If I do cd by itself, it takes me home. So if I do pwd, print working directory, you can see that I'm in the root directory. So very, very easy to use, and I can do cd space .. to go up one directory, and lo and behold, I'm back at the top of the directory structure. Makes it very, very easy for you to navigate around. And you can also, instead of doing cd space or cd enter, you can do cd space tilde, which will take you back to your home directory as well. Now, you've seen me looking at the contents of directories. I can list out the contents of directories with the ls command. So let's go ahead and let's play around with that just a little bit. If I just type ls by itself, it's going to list out all the contents of the directory. However, if I do ls space -a, it's going to show me all the files. And notice how there's really no difference. The files that we see with the ls command are the same that I saw with the ls -a command. But watch what happens when I go to root's home directory. If I do ls space -a, you see all these dot files? These are called hidden files. Now that doesn't mean that they're evil. It just means that they're files that you generally don't use very often. They're configuration data, they're cache logs for individual commands that you use. So it just kind of suppresses that information from you. So if I type ls, if I type ls, it shows me the files that would be of interest to me. If I do ls space -a, it shows me all of the quote-unquote hidden files and directories as well. And once again, please don't look at hidden as though they are absolutely evil. Also, on my version of Linux, you can see that we have different directory colors. You can see that on my system, the directories are blue and the individual files are black. And you can see that I have red files for like dead packages that I can install. Your colors are going to change based on the type of the Linux operating system that you are in fact using. We also have absolute and relative referencing of files. Now I just want to show you guys this one really quick. So if I go back to the command prompt and I go cd space / opt, I'm starting at the top level directory. And then if I do web labyrinth, it takes me into the web labyrinth directory. I'm doing the full explicit path of that directory. All right. Now I can go cd space / opt, and now I'm in the opt directory, and then I can do cd web labyrinth. Web labyrinth. Notice I didn't have to do the / at the beginning because I'm already in the opt directory. You only start with the / if you're starting at the very top of the directory structure. Ejecting the CD or ejecting USB, you really want to get into the habit of ejecting various devices that you insert. Linux and Unix and Macs just aren't nearly as forgiving about just yanking a USB drive out or just ejecting a CD without typing the eject command first. So you want to be nice and tell it to eject it. Making directories is the same way that you do it in Windows. If I go cd home, which brought me back to the root directory, I can do make dir, and then I can do hello. If I do make dir hello, I have just created a hello directory. And I can change directories into that hello directory. Very, very easy to create directories as you need. All right, copying files is very, very, very similar to Windows. You simply copy from source to the destination, except it's not typing out copy. Once again, remember the people that came up with Linux and Unix, they flat out hated typing. So instead of typing copy, we just do cp. So you can see that I'm in the hello directory. Let's say I want to download or pull this QL proxy file into the hello directory. I can do, let's go copy root, and then I can do ql proxy, caf deb, and then dot. Now, that dot means we're going to copy that ql proxy deb file, and the dot directory is the current directory. So I do ls, and sure enough, it copied that file to the current directory. So it's cp source and destination. cp source and destination. Now on Linux and Unix, there's this really cool feature where it goes through and it indexes the entire, it indexes all the files on the hard drive. And you can search for those files. So if I do locate and I do ls, it's going, well, let's do something else. Let's do a spider. So I do locate spider. It's going through and it's finding every single file with the word spider in it. It's a really quick index search of all these files on the system. Now, you might get an error on some of your Linux distributions for classes. Now, if you do get something like says the database is currently 23 days out of date or a year out of date, just run the update db command and it reindexes all of the files on your hard drive. So then you can find things pretty well. Now, sometimes you want to have a more exhaustive search. So I can do find, start at the top level directory, and then name. This is allowing me to restrict my search to just the file name. So if you notice, if I ran spider with locate, it brought back any file with spider in the name. Now if I do the -name with the find command, it's just going to find the file with that specific name. So if we do that, we do find, and we do / start at the top level directory, name, and we'll do spider. Let's just do who am I? Stick with the book. Now it's going to exhaustively search the entire file system, looking for any file with the entire name is who am I. So very, very, very cool, powerful command to find where things are located. Now on Linux and Unix, you have to choose which type of editor you want to use. You can use gedit, of course, but there's a whole number of other editors that exist. VI, Emacs, Pico, Nano, tons of them out there. For people that are just getting started with Linux and Unix, we recommend that you use gedit, and most of the classes will have gedit. And gedit is nice because it has like full WordPad type capabilities. You can use your mouse and navigate around easily, but at some point you're going to have to learn another editor, and I recommend VI. VI is a very, very powerful editor. So let's go ahead and let's play around with VI really quick. So I'm going to cd back to my home directory for root. And we're going to clear our screen with Control-L, and I'm going to create a file. I'm going to touch a file called hi. All right. So I touch hi, hi is created. I don't think I do have gedit. If I do gedit hi, the gedit editor is going to open up, and as you can see, it's really not that bad. I can type stuff in, I can move the cursor around, it's just like you would normally, and I can save it. So I go File, Save. Not too bad. But as I said, you really need to learn VI. VI is just one of the kind of the stalwarts of the Linux and Unix world. I can do VI as another editor, and I can edit the hi file. So I do VI, and I can do, was it hello? Yeah, hi. Do VI hi, and there's my file. Now, I can edit this in a number of different ways. The first thing you got to understand is when you're working in VI, we recommend hitting the A key to allow you to type in additional things into the file. And you can delete and you can add things. Your mouse isn't going to work for moving you around. Visual Editor is merely a text-based editor, and we can do all of the editing that we need to do. Now, if you're done editing a file with VI, you have to hit the Escape key, and then you have to hold Shift and then the colon or semicolon key. It's right to the right of the L on your computer. And it's going to bring this little prompt up at the lower left-hand corner. And then you can hit Q to quit, or you can do WQ to write and quit. So we've changed that file, and I do Shift colon WQ, enter, and I am out. Now there's a lot more that you can do with VI. Just to be completely clear, there's a lot more that you can do with VI. However, it's more than we can go into in this, but I'd recommend just doing a Google search for VI cheat sheet, and there's tons of VI cheat sheets out there to get you started. If we ever want to view the contents of the file, I can use cat to look at that file. So I can do cat, and I can run hi. We do cat hi, and there's the contents of the file. And that cat stands for concatenate, not cow, not like cat, like they're two completely different things. Cat means concatenate out the contents of that file. And I could also use less too. We'll talk about less more a little bit later, but there's a number of ways to do the exact same thing in Linux and Unix. Now, the less command, as I said, we talk about that a little bit more. Years ago when they had the more command wouldn't allow you to do things like searches, it wouldn't allow you to move back and forth in the buffer. So by and large, if you want to edit a file very easily, you can use the less command to do so. And less, if we talked about it on one of the very first slides, is you can use Q to get out of less. So if I go through, I can chain commands together. Let me show you how that works. If I run a command that's going to take just a tremendous amount of data and kick it out, I can do ls dev. And bam, we've got a whole bunch of different things in dev. Well, that could be kind of a bit crazy. So I can take that output and I can pipe it. So I can do ls dev space, and the pipe key is the little key that's right above the enter key on your keyboard. And then I can pipe that through less, and it'll allow me to go up and down, and it presents that data in a way that goes by slower so I can go through it. Once again, Q allows me to exit out of the less command. All right, so let's talk about running programs in your path. Now, let's play around a little bit with the path and what it is. So if I do echo $path, it's going to show me the search path, and it helps to actually type echo correctly. These are all the directories that the operating system will automatically search through to try and find the program I'm trying to run. So if I type ls, ls isn't in my current directory. However, if I do which ls, you see that ls is in the bin directory. And sure enough, you can see the bin directory is in my search path. So this makes it so you don't have to type the exact command every single time you run it. You can just type ls and it'll automatically run bin ls for you. So very, very powerful, very, very easy to try to run programs on your computer system. Now, if you want to run programs that are not in your path, the current directory is not in your path on most Linux and Unix computer systems. Let me show you what that means. So if I go to a program, let's go cd opt and let's do spider trap. If I do spider trap, you can see I have a, oh, that would be a bad one. Let's go to, which one is a set executable? How about keepo? Oh, no, that's Python too. Let's do set. All right, so if I go to the set directory for the social engineering toolkit and I type ls, you can see that we have an executable here called set. If I just type set, it just dumps that to the screen. That's not very cool at all. So if I do /set, it actually executes that program. So you want to be able to execute the program in the current directory rather than the overall set command that would execute. So if I do which set, it's not going to bring back anything. It's not going to find anything. Now if I do /set, it executes it. So this allows us to execute files in the current directory. This is one of the more frustrating things for people that just get started using Linux and Unix because they want to run a program like they do on Windows. You just go to the directory and you execute it. No, on Linux and Unix you have to do the // first. And the reason why is really this is ultimately a security issue. Years ago people would create backdoor Trojans and little evil programs. And if you ran like the ls command, it would execute the ls command in the current directory and then it would take over the computer. Life wasn't good. Dogs and cats were living together. So they got rid of the current directory as an executable path, and now you have to be explicit, // then the program. Now, if you wish to edit your path, and we strongly recommend you do not do this until you've gotten some miles underneath you using Linux and Unix, you can do path equals $path, which is your current path, colon, and then you can add an additional directory, so it can search through that directory. If we want to see what's running on your computer, this is kind of cool. On Linux and Unix systems, I can run the ps command. Let me show you what that looks like. I do ps. These are the processes that I can see that I'm currently executing. You can see I got sudo, su, bash, and ps. However, if I do ps space aux, it's going to show me all processes sorted by user, including the ones associated with a teletype terminal or a pseudo teletype terminal. So now we got a whole bunch of additional programs that are running, which is pretty darn neat. The next thing you can do is you can do top. And what top does is it's very similar to Task Manager on Windows. And whenever top is running, it updates like every few seconds, and it shows you all the programs that are running. Now, this is very, very useful when you're looking for malware. It's very, very useful if you have a process that's hit or hung, and to get out of it, just hit the Q key, and it breaks you out, and you're back to life being normal. Very, very cool to see the processes that are running. All right, so let's talk about some networking stuff. The most important command on your whenever you're taking SANS classes is ifconfig. Now, ifconfig will show you your current network adapter interface IP address. So you can see that mine is ETH0. Yours might be different, but it's 10.12.1.186. Pretty neat. I can also change this to whatever I want it to be. I can do ifconfig, and I can do ETH0, the Ethernet adapter that you see here, and I can give it a new IP address. Let's just give it an IP address of 10.10.10.10. And I hit enter. And now I've officially changed my IP address to be 10.10.10.10. Now, some of your classes are going to use DHCP. To do that, just do DH client and then your Ethernet adapter, and it'll get you a new IP address. And you can see I have 10.10.10 again, and I may not have a DHCP server running inside this VM, but DH client works great for getting you an IP address. Now, if I want to change my IP address back, I can just go back and I can grab that IP address, that 10.12.1.186. I just simply highlight it, right-click, copy. Don't use Control-C because that'll actually kill your current command. And I'll do ifconfig, and then I'll do ETH0, and then I can put back in that IP address that was up above. There we go. My IP address has changed back to 10.12.1.186. Pretty cool. Next, we can ping remote systems. Now, I have this kind of troubleshooting series of steps that I go through in SANS classes called ping port parse. First, if you're having trouble connecting to a server or making something work, ping the remote system to make sure that it's accessible. Then make sure the port is open, and Nmap is a great tool, and you'll learn about Nmap in your classes. And then parse any error messages that you receive. So if I want to find out if Google's DNS servers are up and running, all I need to do is do ping 8.8.8.8, hit enter. Sure enough, it is responsive. So you can see ping 8.8.8, I'm getting a response. You can also ping by names. I can do www.yahoo.com. You can see yahoo.com is responding. But if I do yahoo.dg, it's going to say unknown host. So it's a good way to find out if a system is alive or if a system is dead or not accessible to you. If we ever want to look at network usage, there's a couple of commands you can run. You can run netstat minus NA will show me all of the open network connections. And netstat is kind of nice, but I personally prefer LSOF space minus I space minus capital P. It will show me all the ports, what services are associated with them, and of course, whether I'm listening or I'm talking to a remote computer system. LSOF is a very, very powerful command that you can use. Now, let's talk about building tools. Now, on different Linux and Unix-based systems, you have something called tarballs whenever you're trying to install different programs or move large file sets over. This was created years ago to make life much, much, much easier for administrators because they used to have to copy files over one at a time or write a program to do it. It was just a pain. So what a tar archive does is it takes all of these different files and it combines them together into one file. We call it a tarball. Now, on some of your classes, you're going to have to extract tar archives. If you want to extract the tar archive, you just do tar xvf to go ahead and extract that tar archive. Now, some of your tar archives are going to be compressed. If they're compressed, they'll have like a GZ or a TGZ at the end. For that, you just need to do tar xvfz, and it'll automatically decompress and extract the archive for you. Sometimes you'll be in a situation where you have to install some tools, and configure, make, install allows you to configure the particular tool's code so it matches your specific architecture, your specific CPU, your specific architecture of Linux, and then make install allow you to install that program to the appropriate directories on your system. Some tools, all you have to do is just straight up make. Some of them are just very straightforward. But trust me, in whatever SANS class you're taking, they'll be very explicit about how you're supposed to install your programs. Let's talk about other odds and ends. So the grep command allows you to search for a specific string, and you can also use regular expressions and all kinds of additional things. So if I wanted to find all the files in a current directory that contain the word root, I could do grep root, that's the string I'm looking for, star, and star means all the files in the current directory. Very, very powerful command to find different things. So if I wanted to find all of the listening ports on port 7777, I could do netstat space minus NAP. I can pipe that through grep, and then I can pull out anything that has 777 in it, or I can find any bash programs that are running. Now, one of the coolest things about Linux and Unix is there's something called the man pages installed on Linux and Unix. And what's really neat about the man pages is they're the little manual for all of the programs that exist. So let's pop on over to my system. Let's say you see that in the class we're using a tool called nmap. You're like, wow, what's nmap? What does nmap do? Well, you can do man nmap, and it'll open up the reference guide for nmap. And you can see, oh, well, nmap is a network exploration tool, security, and port scanner. It talks about a description of what nmap does, common example usage, options that are available. Now, many times when you go online and you have a question, you'll go to like a forum and you'll type in, how do I use this particular command? They'll tell you to RTFM. Now, whenever they're telling you to RTFM, they're telling you to read the find manual. And that, in fact, is the find manual for nmap. I've got a man page for the ls command. I've got man pages for the man page as well. So there's all kinds of different manual pages, and this is one of those things that just makes Linux so awesome and easy to use because it has user manuals built into it, which is just great. Now, if you just want a quick hint, what does something do? You can use what is a command, and it'll give you just a quick update on what that particular program does instead of giving you the entire man page. Now, the other thing that you can do is you can try to find every single command that is associated with a particular topic, like networking. So you can use apropos network, and it'll bring back any of the programs that has networking in the description of that, or you can use man-k. Finally, shutting down. If we want to shut down our computer system and just kind of close it out at the end of the day, we can just use shut down, and then we can do -H, and it will halt the system. So you do shutdown -H now, and it's going to go through the process of making my computer system go night-night. And that's putting the active defense harbinger distribution to sleep. So it just shut the computer system down. So Linux is a very, very powerful operating system. I hope that you don't just use it for whatever class you're teaching, but I hope, whatever class you're taking. I hope that you get the opportunity to get to know and love this operating system. And a couple of tips. First, I recommend that you download a distribution like Ubuntu or Linux Mint or something that's really user accessible, and you make that your distribution that you use on your computer. Kind of get yourself away from using Windows for everything. You can either install it on your computer directly, or you could just run it inside of a virtual machine. For getting started, I recommend you download VMware Player and just get started using it inside of a virtual machine. That would be best for now. But really try to do things like surf the internet, watch YouTube videos, try to gain access to your email, try to make your wireless USB cards work. Really just sit down and try to do things with the operating system, because the best way to learn how to use Linux is just to use it. And as you use it, you continue to use it more, you're going to get more and more adept at it, and you're going to start having a very good time. It's a great operating system, and you're going to get a lot of mileage out of it in whatever SANS class it is that you're taking. Thank you so much for your time today. My name is John Strand. I am a co-author of SANS 504, Hacker Techniques, Exploits, and Incident Handling, and I hope to see you at a SANS conference in the very near future. Thanks again.